The Axion particle was first proposed in the 1970s. It was originally meant to solve a major problem in particle physics, but since then it's remained pretty elusive. But today it seems as though we may be on the cusp of its discovery. We're going to dive into the evidence as well as what this might mean for particle physics in the future. But first, be sure to punch that like button, comment when you think I'll finally get a haircut, smash that subscribe button, and ring that bell to never miss a video. I'm Eric Malachite, author of Mind's Horizon, and this is Science Cat. The theoretical Axion particle is thought to be formed in the cores of stars, converting into particles of light when in the presence of a magnetic field. Now, axions have never been detected in any of the stars we've observed, at least thus far. But if they were discovered, they could resolve what's known as the CP problem in chromodynamics, which suggests that the vacuum alignment as observed by the author and collaborators of a study showed certain constraints on CP parameters. CP symmetry claims that the laws of physics should be the same in particles as they are in antiparticles, and indeed, at first, experiments didn't show any variation in physics. In the simplest terms, CP symmetry tends to break down during certain types of weak decay, violating certain laws of physics. Axions were supposed to solve this problem. Axions are also thought to be the elusive dark matter that scientists have been searching the universe for. I probably don't have to go too far into why the discovery of real-life axions would be revelatory for all of science, do I? I am going to anyway, but you know. Since dark matter really hasn't been directly observed yet, there are plenty of alternate theories as to what dark matter could actually be, and a few hypotheses and fringe ideas that suggest that it doesn't exist at all. I'm looking at you, so-called electric universe model. One interesting idea is that information could have mass, but that's something for another video altogether. So let's not get distracted. Focus. A new phenomenon was discovered coming from several neutron stars that are currently under observation, and that is known as hard X-ray excess. The thinking is that the axions that are being formed inside these neutron stars, referred to as the Magnificent Seven, no, not them. And somehow, because these dead stars are composed primarily of, neutrons, they're able to escape into the magnetic field where they're converted into X-rays. Benjamin Softy, Divisional Fellow in the Berkeley Lab Division, is just one of many authors of a new study, which was published on January 12th in the journal Physical Review Letters, which details how this hard X-ray excess could mean that axions are present in the Magnificent Seven. No, not them. Now, the Magnificent Seven are not pulsars, so the strange behavior of X-rays and other types of radiation that seems to come off of them is quite puzzling. Additionally, if there was an object behind these 7 neutron stars, then that object should have shown up in the observational data, but no such object does. The researchers are using 2 different satellites to conduct this research as well: the European Space Agency's XMM Newton and NASA's Chandra X-ray telescopes. So you would think something like this would show up between these 2 points of observation. Now, this isn't to suggest that axions are the only option left as far as explanations go, but right now there isn't really another one. So, okay, it might be a new particle and it might not. What does this mean for science as a whole and our understanding of the universe? That's right, we're getting into some speculation. Well, at least something works right around here. As Philip DeFranco would say, let's just jump into it. Though, hopefully not into a neutron star, because that would be very bad. If this X-ray excess is confirmed to be caused by leaking axions from the Magnificent Seven, stop that. And they're confirmed to be dark matter particles as well, then it's not really hyperbole to say it would mean a revolution for science. I say science is a blanket term instead of particle physics or something, because for the longest time, Einstein's general theory of relativity and quantum mechanics have been at odds with each other, and even efforts made by string theory and its older sibling, M theory, have not been enough to unify the sciences under a single theory of everything. You know, the answer to the ultimate question? No, the answer isn't 42. If these theoretical axions exist, they should behave very similarly to the way neutrinos do in stars. Neutrinos are subatomic particles that don't normally interact with normal matter, and they have a neutral charge, obviously. There are 3 different varieties: electron neutrinos, muon neutrinos, and tau neutrinos. Axions would behave similarly because they too wouldn't interact with matter except in very minuscule ways. Such a discovery would prove that dark matter is real once and for all. Take that, fringe theories, and more than likely would redefine how we see our universe. Think of it this way. In the early 1900s, it was thought that the Milky Way was the only galaxy before astronomers began to realize that these distant points of light, what they thought were just nebulae they were observing, were like island universes of stars. The idea was highly controversial, and the universe seemed to expand exponentially overnight because of the discovery. Something similar might happen if dark matter particles, axions, are discovered, because the stuff is supposed to make up 80% of the known universe's mass. Not only that, but in the realm of space travel, there is a supposed technology that may be able to get us up to 99% the speed of light. And before all of you in the comments go, "That's not possible," hold your horses. Planck photon rocket drives are thought to, theoretically, yes, this is very much in the realm of speculation, thank you computer, reach 99.999% the speed of light. They're thought to work by using photons to drive an object forward. The interesting thing about this proposed technology is that there is some evidence to suggest that driving an object forward with photons is totally possible. The only trouble is that there is no known fuel right now that would convert 100% into light. This technology also relies on the assumption that some of these photons would generate the hypothetical Planck mass particle, creating micro black holes in the process. If axions are both a necessary part of photons and they're also dark matter particles, then if we can somehow uncover how they're made in the cores of stars and neutron stars, then maybe, correct me if I'm wrong in the comments, all you wonderful people with PhDs, we might be able to make these engines actually work. After all, warp drives are thought to work based off of using dark energy or dark matter to warp space-time around them, right? Would axions be able to make those work too? But even if we don't confirm that axions are responsible for the Magnificent Seven's, didn't happen. Okay, the Magnificent Seven's X-ray excess, the research will more than likely improve our understanding of the universe. It just might not be the revolution that the authors behind this paper are suggesting the discovery of axions would be. I guess like most things, we'll just have to see how the story develops and what we can learn from these neutron stars and their odd behavior. If you dug this content, be sure to drop a like and comment your favorite method for faster than light travel in sci-fi. And be sure to smash that subscribe button and ring that bell to never miss an episode of Science Get. I'm Eric Malachite, and I'll see you next time.